নমস্কার সকল ছাত্রছাত্রীবৃন্দকে। My today's topic is about thin layer chromatography in pharmacognosy or TLC in pharmacognosy. Myself Samar Ghosh, Assistant Professor of CIPT and AHS. CIPT, Calcutta Institute of Pharmaceutical Technology and Allied Health Sciences, the second oldest self-financing pharmacy college in West Bengal, with a strong legacy of academic excellence. Now, the TLC, a powerful analytical tool for separating, identifying, and characterizing the bioactive compound in medicinal plants and herbal extracts. Now, coming to the next slide. Introduction. TLC or thin layer chromatography is a planar chromatographic technique used to separate non-volatile mixtures into their individual components. In this method, the separation occurs due to the differential migration of compounds over a stationary phase under the influence of a mobile phase. The stationary phase is a thin layer of adsorption material. Adsorption materials like silica gel or silica gel G or silica gel Ga. The silica gel G means the gypsum. Now, here two phases are there. One is stationary phase and another one is mobile phase. The stationary phase is made up of silica gel, alumina or cellulose coating. And mobile phase is made up of solvent mixtures for components separation. Solvent like NXN, water, methanol, ethanol, etc. Now, why we will choose TLC or thin layer chromatography? The reason is very simple. First of all, it provides very quick result, often within a few minutes. Second one is that it's economical, the cost effectiveness of the procedure. Now, third one is it's highly versatile, applicable to pharmaceuticals, food analysis, forensic samples, and cosmetics. And also, it helps in qualitative analysis, especially for identification and purity checking. Now, coming to the next slide, the principle behind TLC. The main principle of TLC is adsorption and capillary action. Now, there is a difference actually. There is a difference between adsorption and absorption. Adsorption is a surface phenomena in which molecules of a substance accumulate only on the surface of a solid or liquid, only on the surface. Whereas the absorption means, like, if I pour a sponge cube in a bowl of water, what will happen? The sponge cube will absorb the water all over the sponge. Look, like, this is absorption. And absorption example, like, if I draw a line into a paper, then what will happen? The ink will attach on the upper surface of the paper, whereas the opposite side of the paper is completely blank. So upper surface of the paper, the ink is applied. So, like, this is adsorption. And second one is capillary action. And also the third principle is differential affinity, or the partition mechanism. The compound that have the greater affinity for the mobile phase dissolve more easily in the solvent and move faster with it. Now, coming to the next slide, the key components of a TLC system. As I said before, the TLC plate made up of glass, plastic, aluminium, etc. You can make a TLC plate into the laboratory, I will show you a video by which you can make a TLC plate in lab. Also, you can uh, use the ready-made TLC plate for the TLC procedure. And mobile phase, TLC chamber, and sample application. Mobile phase, like you can use the various types of solvent like water, methanol, ethanol, NXN, etc. Based on the polarity, and TLC chamber and sample application. Now I will show you a video by which you can prepare the TLC plate. So the silica gel is applied on the glass material. Here you can see the silica gel is applied, and then it will pour into the dryer. Here the silica gel will dry and we can make the TLC plate. Now coming to the next slide, the TLC procedure. At first, the plate preparation, we have to make the plate as I am said before, or as I am discussed before, and then chamber setup. The prepared TLC plate is placed into the TLC chamber where the mobile phase is there, and then the development phase and detection and analysis. Now I will show another video by which you can easily know how the TLC is work. Here the sample has been applied on the TLC plate. It's a very important step because without sample application we cannot do the TLC procedure. We have to apply in a very small amount. And now the development phase. In development phase, the prepared TLC plate placed vertically into the developing chamber. The solvent must remain below the baseline, otherwise the sample may dissolve directly into the solvent. Now with the solvent, our components is running towards upper side. As you can see here, there is a polar solvent and non-polar solvent. Based on the polarity, component will run. So here you can see based on the polarity. And solvent front reaches near top of the plate, and then the plate is removed. So when the solvent front reaches the top of the plate is removed. Then drying is important step. We have to dry completely. After drying, the plate is ready for visualization and analysis. Now, for visualization, most compounds are colorless, so we cannot see in the naked eye. So visualization is necessary to detect separate spots. So for visualization, we are using UV light detection. Under the UV light at 254 nanometer or 366 nanometer, compounds we can see. If we can see in the naked eye, then it's okay. Otherwise, we have to use the UV lamp. And another technique is this is the iodine, ninhydrin, potassium permanganate, or vanillin. These are the chemical reagents. These are the chemical reagents. Like ninhydrin. Ninhydrin detects the amino acids. Please note down, ninhydrin detects amino acid, where the sulfuric acid detects the organic compounds. We can spray and we can detect the RF value. Like RF value means the retention factor. Distance traveled by the sample by distance traveled by the solvent. By this procedure, we can calculate the RF value. So as I am said before, this is a visual techniques. Like if we cannot see in the naked eye or normal eye, we have to place in the UV light detection or chemical spray. Now, the application of TLC. The main application of TLC in pharmaceutical analysis. It is used to check the drug's purity and detects the impurities. Also, it helps to determine the reaction monitoring. And also purity and adulteration testing, chemotaxonomical studies. In some forensic report also, TLC is applied, and quality control. And in some cases like poisons are there or not, toxins are there or not, like these types of tests, we perform the TLC. And TLC is very fast, cost effective, and very simple. Like in case now advantages of TLC, like it's very much cost effective, rapid result, it's given the high throughput and versatile application. Cost effective, like in case of HPTLC, the HPTLC machine cost is very much high. So rather than HPTLC, we can use TLC. Otherwise, it gives the rapid result. In case of HPTLC, we need or we require a very trained person. In case of TLC, anyone can use or any students can use very easily. Now, TLC is a very vital role in pharmacognosy. Its rapid discovery and characterization of bioactive natural products. It's ensure the quality control and authentication of medicinal plant materials. Also provides cost-effective screening for phytochemical profiling studies. So that's all for TLC. I hope everyone can understand about the TLC. With the help of animated videos, with the help of uh, the presentation, I think all doubt is clear. Otherwise, in my class, you can question me or ask me about your queries. So ধন্যবাদ সবাইকে, ভালো থেকো, সুস্থ থেকো, নমস্কার।